Hey everybody, welcome back to the channel. Today we're going to start the physical upgrade of the MEC instrument. So we've been working on a bunch of electronic and device related things for MEC, but today we're going to start actually working on the hardware. So I'm going to bring you through our first major hardware project. So that starts here. On the left panel here, we have the MEC instrument as it was in Hawaii. This is a CAD model that includes a lot of the major parts of the cryostat. So let's take a look inside. First, we can make this outer radiation shield go away. And that shows the, now we're looking at the 77K radiation shield. We can take that visibility off. And now we're looking, the 4K shield is right down here. So we can make that go away too. All right, so now we're looking at the fridge naked. The pulse tube keeps, it gets us to 4 Kelvin. Then inside this, there's a big 4 Tesla magnet. And this complicated structure right here, this is an adiabatic demagnetization refrigerator. This is the system that gets us down to 100 millikelvin or below. Down at the bottom here, this is our device suspension. So the light comes in through these windows, and then the device sits in the back of this area. The blue transparent thing is a magnetic shield that keeps magnetic fields out. So this is what our original instrument looked like. On the right here, we've got MEC Prime. So I'll try to put them next to each other so you can see what we're doing. Basically, for MEC Prime, we're adding these parametric amplifiers. They're these quantum limited amplifiers with noise temperature basically as good as quantum mechanics allows. And to make this work, we actually have to add a lot of space to the fridge. So what we're actually doing is we're going to add about 12 inches vertically to the fridge. And in that, we're going to add this Simon Chase GL7 sorption cooler. This uses helium-3, which gets scooped out of the center of nuclear bombs and then recycled for physics in here. That allows us to cool down to 300 millikelvin, and it has a lot of cooling power. So we're going to put our parametric amplifiers down on this metal plate right here. They're going to attach to that. And then this GL7 will fit in and cool all the amplifiers. So to do this, we're adding about 12 inches to this setup here, about 30 centimeters. So the way we're doing it is we're just going to basically add these new supports. You can see these support lines here, like this bar and this one. And then everything will essentially just drop down about 12 inches. And we got another shield extension from the manufacturer that will allow us to just add another a shield. So the fridge is going to get taller, but the first thing we have to do to make that happen is we've got to make these extensions. So I had our machine shop make up this simple copper rod, and also I had him make up a bunch of these little end caps. You can see these little end caps right here. What I'm going to do today is I'm going to build a jig that lets me glue up these parts right that you're seeing right here. These parts are we're going to make them out of G10, so basically fiberglass that's designed for cryogenic applications. Then we're going to glue them in place, but to make sure the ends are perfectly flat and they're at perfectly the right length, I'm going to first machine some jigs so that I can glue them in place in one go. We're using fiberglass because it's light, it's strong, and it has very low thermal conductivity. That's the thing you really want. In this case, you see we have a copper rod. That's going to take all the heat. But the more copper you have, the longer it takes to cool down because you have more thermal mass, more thermal inertia at low temperature. So you want to minimize that. So we've got one copper rod, and then the other supports are going to be made out of this G10 that is an extremely good thermal insulator. All right, so now we go and make the jig. So there's a little, it's off by the tiniest little bit. Probably because the dimensions aren't exactly right, but there we go. Got it. Now we need to machine this thing. Okay, got our stock now, so now we can go set up the cam for the machine. All right, so now we have a complete setup. Let's see, let's do the simulation one last time. This is going to take a total of 15 minutes for the total machining time. Okay. Let's go through here. Okay, cut off the top. Gonna do our pass. Then we do our slot clearing. Our big slot gets rid of that. Then we get that, and I think we'll have a usable jig. Okay, so now we're done here. It's time to move to the machine. All right, now we're at the machine. Haven't used it in a little while, so we got to do a normal warm-up procedure on it. All right, we're back. It's quite a bit later in the day. Turns out my coolant system needed work. I had to refill with distilled water. I ran out of distilled water. The distilled water shop was closed on MLK Day, so I got some from the grocery store. But then I went in there and looked, and everything was messed up. When you're machining copper and aluminum at the same time, the copper chips are heavier, I think. They settle out without going all the way through the chip auger, and you tend to take little chips because it's gummy, and then those little chips can get caught in the water system, and then they kind of like, they corrode a little bit and form a bit of a plaque. So I had to get in there, clean all that stuff out, refill with distilled water, but I think we're ready to go. Change the filter too, it's important. All right, so we're ready to go. The next thing we have to do is machine our jig. So first we got to stick this into the machine and then get started. So let's do that now. All right. Okay, so this has a couple holes in it that might get in the way. So I'm going to use this side and we'll stick it in now. All right, we've got tool one is our 1/2 inch end mill. We got our 1/8 end mill in there. Everything looks good. Now we need to probe the location of the starting point. Here's the probing operation. Z, X, all right, and we're ready to machine. All right, for you professional machinists out there, remember I'm a physicist, not a machinist. All right, let's take a look. All right, I think our jig could use a little deburring, but ready to go. All right, the next step is to cut this G10 rod. This rod is special cryogenic G10 that we ordered custom, 1/16 wall, 3/8 inch. So it has some flex to it. This stuff is nasty to breathe, so I'm gonna wear a mask. All right, now that we got this we can set up the jig. Okay, so let's do a test fit. So we've got these two pieces of end caps that we got from the shop. Notice if you can see, there's a tiny hole in the end in a vent. This is so that when we pump this down to vacuum, air can get out. You don't want to trap air in here or else it'll freeze and increase the thermal conductivity dramatically. All right, so that's what's supposed to happen. Both ends are supposed to go in here. And, whoa, someone cannot do math. So, okay, so now we've cut this to length. I actually went in, I cut it a little long, and then touched it up on the belt sander. Now I'm gonna put these end caps on and the correct ball driver, and we should be in business. Yeah. All right, I call that a good glue jig. Okay, so let's get ready for our glue up. Okay, got some nice, had some nice on the outside there. I'm gonna get a little bit on the inside just to make sure that it's gonna
that the glue doesn't all get pushed out. Inside covered, outside covered. All right, got one. Now let's put it in. Looks like a solid connection. So now we'll just sit and let it dry overnight. All right, it's the next day. It's been about 18 hours. I left the packet as a witness sample to see if it's hard. It's pretty hard. It's probably not fully cured, but it's probably close enough. So now I'm gonna take the support out of the jig and we will see where we're at with it. All right, and there we have it. This leg looks real good. Feels solid. I'm not gonna put pressure on it till it's had a little more time to cure because it's kind of cold out here in the shop, but that's ready to go. So now I need to make 4 more of these, but that are slightly shorter for the design. And then we'll be ready to go. So follow on that process and don't forget to like and subscribe. Thanks.